Guys, in chapter 5, we study about forces in matter. Our group has Haling, she's the captain, Hongzhen, Tuyen, and me, Haming. Now we'll go to the first lesson. Chapter 5.1, forces acting on solid. So these are the different ways of deforming an object. This is, for example, this is an undeformed object, and these are the ways that you can deform it. You can straighten it into two ways, and the force acts on it called tensile forces. You can compress it, and the first is called compressive force. You also can bend it, and bending force will act on it, and finally you can twist it, and the torsion force will act on it. So the object can be deformed temporarily or permanently. So these are the examples that you can know more about it. So for example, when a football is kicked, it's compressed for a short while, and then it springs back to its original shape as it pushes itself to the foot of the player who has kicked it. So it just could be compressed and deformed for a short while, not for a long time. So this is a temporary deform. So another example is when two cars collide. The metal panels of their bodywork are bent. So in some serious car crashes, the solid metal sections of the car's chassis are also bent. This is because the car is less springy, so it becomes permanently deformed. As you can see here in this picture, the car is permanently deformed, and it cannot return to its original shape because it is not springy like a football.
Point 2 about stretching springs. So firstly, how does spring function? Springs are designed to stretch a long way when a small force is applied, so it's easy to measure how their length changes. So you can see in the picture here is illustrate the spring is the blue part, and a force applied is the orange part. And you can see that when a force is applied to the spring, it is stretching the spring downward. So about the investigation on stretching a spring. Firstly, the spring is hung from a rigid clamp so that its top end is fixed. Secondly, the weights are hung on the end of the spring. It refers as the load. You can call it the load. And thirdly, as the load is increased, the spring stretches and its length increases. So the picture illustrates to you how you can organize an investigation on stretching springs. About the extension of the spring, so it is the increase in length of the spring known as the extension. And in this topic, you must be able to calculate the extension of the spring is necessary, and the length of the stretched spring is equal to the original length plus the extension. To continue, let's talk about Hooke's law. So the Hooke's law states that the force applied on the spring is equal to the spring constant times the extension of the spring, and these quantities are represented by the letters F is equal to K times X. And remember, the extension of the spring is proportional to the load applied to it, provided a limit of proportionality is not exceeded. So about the limit of proportionality, at a certain point, the graph bends and the line slopes up more steeply, and it is known as the elastic limit. If the spring is stretched beyond this point, it will be permanently damaged and will not return all the way to its original length. It had been inelastically deform. So you can see here on the graph, the little green dot is represent the limit of proportionality, and the pink line is like the spring constant, and the force is proportional to the extension as long as you don't go past the limit of proportionality. So you can see here is the spring constant is like go constantly upward, but when you pass the point and you will like bend it, and it cannot return to its original length or its original shape.
So 5.4 will talk about pressure. About pressure. Pressure has an important role in our daily life. It is the force acting per unit area at right angles to the surface of an object. Pressure of the water. If you dive into a swimming pool, you will experience the pressure of the water on you. That's because the weight of the water above pressed down causes water pressure. The deeper you go down the water, the greater the pressure acting on you. Water is much denser than air, so the pressure caused by water is much greater than the pressure that's caused by air. Submarines, marine exploring vehicles, dams must be designed to withstand very great pressures. On the right is an example of a protective suit which will stop the deep sea divers from being crushed by the pressure under the water. A manometer is a simple instrument for showing the difference in pressure between two gases or liquids. Manometer is a U-shaped tube holding a small amount of liquid. When both ends are open, the levels of the liquid in the two sides are the same. A barometer can be used to measure atmospheric pressure. Example, a mercury barometer is shown in the picture below. A barometer can be used to measure atmospheric pressure. A long glass tube is filled with mercury and then carefully inverted into a trough containing mercury. When the atmospheric pressure is high, the air presses more strongly on the mercury in the trough so that it rises further in the tube. If the pressure falls, the force on the mercury decreases and the level in the tube decreases. 5.5 Calculating pressure. A large force pressing on a small area gives a high pressure. From what we learned from the previous chapter, pressure is the force acting per unit area at right angles to a surface, and we can write an equation for pressure. Pressure equals force divided by area. The unit for force is newtons, for area is square meters, and for pressure is newtons per square meter or Pascal. We have known that the deeper one dives into water, the greater the pressure. Pressure is proportional to depth, and it also depends on the density of the fluid. We can write the equation for the pressure at the depth h in the fluid of density P is pressure equal depth multiplied by density multiplied by acceleration due to gravity. P equal h multiplied by P multiplied by G. P represents pressure, h is depth, P is density, and G represents acceleration due to gravity.